Hello students, in class 12th, today I will tell you about the reverse breakdown. You know that when the diode is connected in the reverse biasing, then the current in the circuit is very small because of the minority carriers. And after a certain value, the current increases. So this process is called the reverse breakdown. In reverse biasing, of junction diode. Junction diode. Initially, the reverse current is very less due to minority carriers. But when voltage is increased beyond a definite voltage, the reverse current increases abruptly. This process is called reverse breakdown. And it can be seen that suppose here we have this is now 0, this is your x, this is y, this is your x dash, and this is your y dash. Here we take the reverse voltage, and this is now reverse current. Then you can see that we are getting a curve like this. So you can see that initially here up to this one mark, this is, you can see the current is less one, and then this voltage is called the reverse breakdown voltage. This is a different voltage, and it depends upon the doping and the nature of the crystals also. So this is the voltage VRB. So this VRB, this is the reverse breakdown voltage. And you can see from here that at the voltage the potential at which reverse breakdown takes place is called reverse breakdown voltage. So the reverse breakdown voltage breakdown, this is of two kinds. This breakdown is of two types. Number one, avalanche. Breakdown. And third is general breakdown. Now first I will take the avalanche breakdown. Avalanche breakdown. In reverse biasing of junction diode, the current is due to minority carriers. These minority carriers the covalent bonds in depletion region are broken due to collision of minority carriers. They produce electrons and holes, which further strike with next covalent bonds. Next covalent bonds producing new electrons and holes. This process continues. This process continues, and a large number of electrons and holes are produced. Which increases the reverse current abruptly. It is called avalanche breakdown. Avalanche breakdown. The reverse current being high, the diode may damage due to heat. As we know that this heat is proportional to square of current. So to avoid it, avoid the damage, the applied voltage is decreased. Decreased before it happens. Before it happens. Now this is what the avalanche breakdown. Now second that I take it here is your Zener breakdown. Zener breakdown. when doping in diode is high, the thickness of depletion layer decreases. The electric field due to applied voltage increases due to low thickness of depletion layer. So this is what the electric field. This E equal to V upon D. When D is less, then E will be more. So when a small voltage is applied, the electric field is very high. In this case, because of the electric field, the electrons are taken out from the bonds. The electric field due to the applied voltage increases due to because of low thickness of the depletion layer, and you can see that the electric field so produced breaks the covalent bonds and electrons and holes increases. Due to increase in case of minority carriers, the reverse current increases suddenly. This kind of breakdown is called Zener breakdown. So Zener breakdown takes place when the doping is very high. Doping diode is high, the thickness of the depletion layer decreases. The electric field due to the applied voltage increases because of the low thickness of the depletion layer. This is the formula. So you can see that in this case also the number of minority carriers increases and that the reverse current will increase. So Jenner name is given to you because this was invented by C. Jenner. The voltage at which breakdown takes place is called Jenner voltage. And you can see that the name Jenner this breakdown was discovered by C. Jenner. So it is named Jenner breakdown. So this is about the reverse breakdown. And reverse breakdown that I told you is two kinds, avalanche and the Jenner. And in case of avalanche and Jenner, both are the different kind of breakdowns. In case of avalanche, there is the collision of the minority carriers with the covalent bonds, from which they liberate the electrons and they produce a hole. The hole is produced, so electron and holes are produced. This electron further strike with the next covalent bonds and they further increase the number of electrons and holes. Thus the number of electrons and holes increases continuously and that increases the current. So this is the avalanche, and in Jenner this is just different. Jenner breakdown will take place when there is high doping in the crystal. Because of high doping, the thickness of the depletion layer decreases, and when some voltage is applied, the strong electric field will be produced. This strong electric field will pull out the electron from the covalent bonds, and again there is the production of electron and hole. So the number of covalent bonds are broken and the number of electron and holes are created. So they increase the current. So this kind of breakdown is called the Jenner breakdown because it was discovered by C. Jenner, Charles Jenner. So on the name of this scientist, it was given the name Jenner. So you can see that both the breakdowns are different. So you like, share and subscribe this video. Thank you very much.